Another inequality for us to tangle with. So, what do we do first? Check if there's a 0 on one side. Yes, there is. Good. Step 2, factor if possible. Well, minus 3x doesn't get too much better. Can we factor this, the denominator? Yeah, we can. It's a difference of squares. So it factors very nicely. It factors to x plus 2, x minus 2, greater than or equal to 0. Okay. Going all right so far. Oops, there should be an x in the numerator. That's more like it. Okay. So when we get to here, what's our third step? Something about critical values. We look for places where this expression on the left either equals 0 or is undefined. And in this case, there are 3 interesting spots. From the numerator, we get x equals 0. The whole thing goes to 0 if x equals 0. From the denominator, we get if x is negative 2, then the whole thing is undefined. And for the second term, we get if x is positive 2, the whole thing is undefined. So, 3 critical values. And here's a number line for all those numbers to live on. We have to track negative 2 and 0 and positive 2. And I'll get a table built for all that. Lots of intervals to check, but you get fairly fast at this after a while. It's not going to be too terribly bad. For factors, we have minus 3x, which I'm going to treat like a single factor. You could take minus 3 and x and do them separately. That would be fine. This is usually, this is a chunk we can probably manage all at once, so I'm just going to take that as one piece. Then we have x plus 2, and we have x minus 2. And then we'll have like a grand total line where we do the entire expression at once, where we will have minus 3x over x plus 2, x minus 2. Sometimes as a shortcut, I'll just write f of x here to mean all of these pieces put together, but it's not so bad to show all the individual components. It helps remind you what's in the denominator and what's not. Okay, so let's get some signs into this. If x is lower than negative 2, let's say it's negative 3 or something, then negative 3x will be positive. If x is negative 2, we'll get like positive 6. If x is negative 1, we'll get like positive 3. If x is 0, we really do get 0. If x is anything positive, then minus 3x will come out negative. So there's that term. X plus 2, if x is a big negative number, this will come out negative. If x is exactly negative 2, we'll get 0. If x is anything higher than negative 2, then we start getting pluses from here. And for the x minus 2 term, we get negative, negative 2 minus 2 is negative, negative, 0 minus 2 is negative, still negative, 2 minus 2 is 0, and if x is anything bigger than 2, this comes out positive. So, if you put all the pieces together, here we get plus over minus times minus, that's plus over plus. The whole expression's positive there. Here we get positive over 0 times negative, which is positive over 0, which is undefined. Here we get positive over positive times negative, which is negative. Here we get 0 over positive times negative, which is 0. Negative over positive times negative comes out positive. Negative over positive times 0 is undefined. And negative over positive times positive comes out negative. Good with all that? Once you have the sign table, it's just a matter of going back to your original inequality, or the factored version of it is just as good, to see what parts of this, which of these things are in our solution. Our solution is everywhere that this thing is greater than 0, meaning positive, or anywhere it's exactly 0. So we're looking for pluses and zeros. So we get solution here. Undefined, no good. Negative, no good. 0, yep. we'll take 0. Positive, yeah, we'll take that as well. Undefined, nope. And negative, nope. So our solution is anything lower than negative 2. I'm going to say from minus infinity up to minus 2, but not including. And then we get 0. 0 is included. And anything from 0 up to 2, but not including 2. At 2 it was undefined, and that's not good enough.